Good morning, guys. It is April 23rd, 2020. You guys are awesome. You've been doing a great job. Here is the riddle of the day. Please post your answer privately in Google Chat, and then you will receive 10% extra credit on today's assignment. So here it is. A small number of cards has been lost from a complete pack of playing cards, which has 52 cards. If I deal among 4 people, 3 cards remain. If I deal among 3 people, 2 remain. And if I deal among 5 people, 2 cards remain. How many cards are there? So please remember to post your answer privately to me in Google Chat so you don't reveal your answer to everybody else. And the way to do that in Google Chat is just tap on my name and you can send me a private message. All right, here we go. Today, we're going to just review. We've been learning a lot of different things over the last, since we started remote learning on April 13th. So I just want to make sure that we put it all together today. So we'll do a quick review, and then your assignment today will be about just going through everything you learned over the last 2 weeks, remembering that, and really proving to yourself that you understand it. So first thing that we talked about on April 13th was this idea that we could write expressions in different ways, right? We can write an expression in expanded form. We could write an expression in factored form. Remember, in factored form, factor should indicate to you we're multiplying, and in factored form, we're using multiplication. You're going to see the parentheses. So that was the first piece of this. And then we talked about if we have an expression in factored form, like this one. So this is in factored form. The question was, how do we transform that into expanded form? And what we do is distribute or multiply, and we talked about doing that with expansion boxes. So if you look at this, 5x squared plus 7x times the quantity of 4x squared plus 10x minus 3. Notice my expansion boxes are 2 by 3 because I have 2 terms in the first expression and 3 terms in the second expression. And then what I do, and we talked about this, and you've done an excellent job with this, is we multiply each of our boxes to find the product. So 5x squared times 4x squared is 20x squared. Is 20x to the fourth. That's important to remember. Remember, when we're multiplying the exponents on a variable, we add them. So 5x squared times 4x squared is 20x to the fourth. 5x squared times 10x is 50x to the third. And then 5x squared times negative 3 is negative 15x squared, and so on. And then what we do, notice this, is we're going to have some like terms here, because now we have to combine or add together all the parts inside the expansion boxes. So I'm noticing my like terms. And this one over here is a not like term. Okay, so now I'm just going to combine like terms by adding all my pieces. And I'm going to do that in order from the highest degree to the lowest degree. Remember, degree is the number of the exponent on the variable. So 20x to the fourth will come first. And then I'm going to add together 28x to the third plus 50x to the third. And that's going to be plus 78x to the third. And then I have 70x squared. I'm going to add that to negative 15x squared. That's the same as 70x squared minus 15x squared, which is positive 55x squared. And then I have negative 21x at the end. And there you go. All my like terms have been combined. So that means the expression, the quantity of 5x squared plus 7x times 4x squared plus 10x minus 3 is equivalent to the one I've created below, 20x to the fourth plus 78x to the third plus 55x squared minus 21x. And then after we talked about expanding expressions, we looked at this property of zero product property. Now this is, we're thinking about this when we're looking at equations, and we've known this for a long time. If you have two numbers that you multiply together and you get a product of zero, one of those numbers or both of those numbers have to be zero. So we are going to use this property to help us solve more difficult equations in algebra. So take a look at this. The quantity of 2x plus 5 times the quantity of 3x plus 12 equals 0. So that means either the yellow expression or the orange expression have to equal 0. Or both of them. They both could equal 0. So I'm going to write out two equations to figure out what x is. Either 2x plus 5 has to equal 0, or 3x plus 12 has to equal 0. And then I just solve for x. Subtract 5 on both sides. I'm going to get 2x equals negative 5. And then divide both sides by 2. I'm going to have x equals negative 5 halves. I could just leave it like that, negative 5 halves. I could rewrite it as negative 2.5, but I could leave it as an improper fraction. Same thing on this equation here. I'm going to move this over. Subtract 12 on both sides. You could probably already do this one and see this one in your head. 3x equals negative 12. Divide both sides by 3. X equals negative 4. So your solutions are x equals negative 5 halves and or x equals negative 4. So that's zero product property. Now let's talk about what we did a couple days ago, factoring. So expanding is when you're using the distributive property to multiply factored form and transform it into expanded form. Now, if we want to go the opposite way, if we want to go the opposite of distributive property, that's called factoring. It's dividing out. And one tool we use for that is dividing out or factoring using the GCF, which is the greatest common factor. So if I have 8x to the third plus 12x, I'm going to find the greatest common factor between these two terms. And I start off with the coefficient part. What is the largest number that will go into 8 and 12? Divide in evenly. Or what? It's like saying, what is the greatest common factor of 8 or 12? 8 and 12, it's going to be 4. So I am going to factor or divide out 4 from the original expanded expression. So if I do that, if I divide out 4, that's the coefficient piece, but now I got to think about the variables. Each term, the first term has x to the third power, the second term just x. So I could divide out or factor out at least an x in each of these. So what I'm going to do here is, actually the greatest common factor is 4x. All right, so now let's think about it. So I divided out or factored out the 4x. Now, the way to figure out what's left when you divide out the 4x is just to think about it if you were doing the distributive property. 4x times something gives me 8x to the third. Well, that's 2x to the second power. 4x times something gives me 12x. That's going to be plus 3. All right, here we go. So now we have 4x times 2x squared plus 3. And that is in factored form now. So we know that this expression here is the same as this expression here. And I always like to just check, I like to check it by just doing it in my head. 4x times 2x squared, yes, that's 8x3, 8x to the third power, and 4x times 3 is 12x. Let's move on to the final part of this. I'm actually going to change the equation on this one. I don't like this equation. All right, so now what we're going to do is we're going to solve equations by factoring out the greatest common factor and then applying zero product property. So now we're using factoring and ZPP, or zero product property, to solve an equation. So here is an equation. 3x squared plus 9x squared equals 0. So remember, when I solve an equation, I'm trying to find the value of x that makes it true. And right now, how it's written, it's going to be very difficult to do that. So remember, if I'm using zero product property, I need to have this expression here written in factored form. So let's do that. I'm going to divide out the greatest common factor. The greatest common factor of 3x squared and 9x squared. 3x to the third. Let me go back and rewrite that. This should have been 3x to the third. Let me go over this. 3x to the third plus 9x squared. I apologize, guys. So, what is the greatest common factor of 3x to the third and 9x squared? Well, the coefficient part is 3, and the variable part is x squared, so I'm going to divide out 3x squared. Now to go from 3x squared to 3x to the third power, I need to multiply by x. And to go from 3x squared to 9x squared, I'm going to multiply by 3. All right, remember, now I have two equations, either this piece or expression, or this piece has to equal 0 because I have a product of 0. So 3x squared must equal 0, and or x plus 3 must equal 0. Divide by 3, I have x squared equals 0. What times itself equals 0? That's 0. X equals 0. And on this side, x equals negative 3. So my solution here is x equals 0 and or x equals negative 3. All right, guys. Work on your problem set. You're going to have a mix of all these problems. Work on it. Turn it back in. If you show yourself and me that you know what you're doing, you're going to earn 10 out of 10. If you're still working on this, I will give you feedback. And once you correct your work and demonstrate that you understand the concepts, then you will get full credit. You will get 10 out of 10. Plus any bonus points for answering the riddle. All right, guys, have an awesome day. Remember, keep up the work, and I will talk to you tomorrow.